Thank you very much for this nice invitation. My name is CarolinaArchut. I am from the Institute of Rail Vehicles and Transport System of the RWTH Aachen. We are not German railways. They have similar projects, but we have a project from the German government. So this is what I present here. Mechanical weeding, pressurized water, and electroweeding on railway lines. Thank you. So I would like to start with a small overview of the project. And afterwards, why do we select these three methods? How did we build our test vehicle, our future work, and conclusions? So this work is part of the project development of an alternative method to chemical vegetation control on railway tracks. As I said, this is a project of German government. Yeah, we aim to create a scientific basis to develop new or to adapt existing herbicide-free methods. We try to avoid the word non-chemical because water is a chemical. So we say herbicide-free. And yeah, our goal is to test these methods on field trials and assess their efficiency and feasibility. Originally, the project duration was 3 years. It was 1 year extended. You know, when you are manufacturing, constructing, everything could go wrong. So now it is 4 years. On the first phase, we select and develop the method. So we did the construction of the test vehicle and the assembly of everything. And the second phase is where we are now. And this is what we are doing on the next vegetation season, assessment of efficiency and suitability in field trials. And then the third phase is elaboration of recommendations for action. So how can we continue applying these methods? What do we need? First of all, we did an analysis of the state of the art. When you are developing a product, you start asking, what do we need? What are the needs of with management on railway tracks? So we start compiling requirements. We had a long list, about 80 or 90 requirements. But for the selection of the method, we took only the effectivity, efficiency, usability, safety, and environment requirements. They were about 22 requirements. And afterwards, we start doing literature research of herbicide-free methods. We analyze thermal, mechanical, electric, and radiation-based methods. So thermal is like the tendency, and everybody was asking what is about thermal. So we took a bit more time analyzing this part. There were a lot of gaps in the literature, and we started doing experimental filling of gaps. So small experiments or laboratory experiments with some models, but also on tracks. We mostly apply different doses, different energy requirements. We analyze all this stuff. Yes, it is a lot of energy. When we are talking about thermal, we try both. We try cold, we tried also heating. So it was dry ice, what we apply on the plants, and it was also hot water. And yeah, we could see the mode of action of thermal methods is you have to kill the root, you have to achieve temperature on the root. And if you don't achieve this temperature on the root, then the plant will grow up even faster if we are talking about heating. When we have this ballast soil, so it's different. It is a challenge to achieve this high temperature on the ballast. We try also several ballast levels, and we measure temperature on these levels, and we saw how difficult it was to achieve 60 degrees on the bottom. And all this kind of experiments help us to decide, okay, is this possible to apply this technology in a big scale? We also try UVC experiments, different doses, and some other stuff. So afterwards, yeah, we had some information about all the methods, about plants were growing, and we start rating the non-chemical methods, the herbicide-free methods. For this, we had the requirements, we had information about the methods. The requirements were weighted, as said before, or yesterday, I think. And not all requirements are same important. In Europe, yeah, environment, it goes always on the top, and then human safety, and then the cost. Yeah. So we did also this weighting of requirements. We also prepare every requirement with a specific scale. So we try to quantify the fulfillment level of every requirement. And then this is how we achieve these rating points. So for every requirement that I show here, we did a scale. And then we saw, okay, how every method fulfill the requirement, in which level. There was high divergence on literature data. So we tried to map this divergence, and we split the range in best and worst case. So where the literature said we are doing the best, we have the best method, this was maybe those were the best case. It could be that this is an ideal situation because the plant react to the method, or the weather conditions were good. So this is like the best case. And worst case is where we found in the literature, okay, this method doesn't work, throw it away, and so on. Afterwards, we got our range. And in both cases, best case, worst case, mechanical weeding, electroweeding, and pressurized water were on the top. I mean, manual weeding was also there. There is where you can see humans are very smart and they can kill and they can remove small and big plants. And but this is not the future. We don't want to set a group of 20 people and start pulling weeds. So we said, okay, it's good. But we are not developing this method anymore. So we take these three methods: mechanical weeding, electroweeding, pressurized water. I have here a picture of all of them. Mechanical weeding is pulling out the weeds. So there are some cylinders. I will explain better in next slides. But these cylinders, they rotate against each other, and this is how the plant is weeded. Pressurized water is mostly water jet, and we are cutting off or fraying the plant. And electroweeding is desiccation of plants through electricity. This is the schematic view of our test vehicle. We did the design based on the guidelines for construction because we wanted to analyze a lot of solutions. It took us longer. But this method helps you to work systematically and to analyze several cases. We took a road rail vehicle. Wait, sorry, I spoiled it. We took a railroad vehicle because we have to move from place to place, but on the street of course. We don't have still the homologation, but yeah, it helps us to work on the street and on the rails. Here on the test vehicle are all the power units, generators, high pressure tank, water tank, the pump, and so on. After we have this tower carried model here, and yeah, there is where our applicators are distributed. So electroweeding is yellow here. Those are our applicators, and on red is mechanical weeding. And here this purple, they are the high pressure water jet nozzles. We also took a foldable boom because in our task it was defined to treat the whole track, not only the part here where the rails and sleepers are, but also the flanks, the ballast bed flanks. This is foldable, so when something is coming here on the track, then we can put it back. Yeah, this is how it looks like. This is our test vehicle in reality. Yes, the road rail vehicle and the towed carry model with the foldable boom here. Mechanical weeding. So I said working principle is pulling out plants through rotating cylinders. The force is about 160 newtons. It can be reduced when we are working on grass. If we are trying to pull out blackberries, then we might need double force. This is why we got these motors. You can see they are very big. But actually, we had very small motors when we did the test. When we did it in a small scale, it was only a small motor. Yeah, this is mainly used against grass and plants with strong shoots. Otherwise, the plant break, and this is kind of mowing. And the advantages is that the power requirement is very low. So for each motor, we need about 1.6 kilowatts. Yeah, you can achieve this very easy with a normal generator. There is effectivity regardless weather conditions. We are not depending on weather. So you can work in winter also. We can plan and say, those are our appointments for the next treatments, and we are not aware if it rains or not. So that's good. There is a possible effect on plant roots, as I said, for grass mainly. We can see here the root comes completely out. And there is no need of substance application. So there are no questions if it is environment friendly or not about the substances. I mean, of course, there are always some questions about plastic wear and if the particles don't stay on the track and so on. But till now, we haven't seen anything. Also, there are not big holes on the ballast. It is only sometimes the highest the highest level of the ballast, which is a bit removed, but also not every time. Challenges, of course, is working speed. Currently, we achieve 7 kilometers per hour. Yeah, let's see if we can increase it. And the operation on uneven surfaces, because as you know, ballast flanks, they are not constructed as in the pictures. And yeah, you have to avoid the collisions. Yeah, I'll go to the next method, pressurized water. Cutting or fraying plants through water jet. We have 150 megapascals. This is huge. because we want to achieve very high working speed. So this is why we have to apply a lot of pressure. Also, the distance to the plant is almost 20 centimeters. So when you have high speed and you have distance to the sample, a high distance to the sample, then you need a lot of pressure. This is why we came to this 150 megapascal. We apply abrasive. This is sand mostly, 200 grams per minute. This is very, very less. It's about like a spoon of sand per minute. And we apply this close to the rails and on ballast shoulders. Why? Because you can apply this in very narrow areas. You can direct the jet, and yeah, then we can work with this method close to the rails. We use this method mainly against leaves and shoots up to 6 millimeter thick. Yeah, low water flow. This is one advantage. 2.8 liters per minute was already. We still continue doing a lot of experiments, and there is also effectivity regardless weather conditions. So challenges are also the working speed and avoiding cables and plastic components on the track. We already saw if you apply water jet on these components, they can break. And the next one is electroweeding. It's the plant desiccation through direct current. So we have about 2,000 to 5,000 volts. Why direct current? Some research on alternative current show that you kill the plant through heat, but we are not trying to kill the plant through heat, but we are trying to divide the cells. And this is how the plant lose water, lose bundles to nutrients. And this is after some days, the plant die. It is mainly used against herbaceous and non-woody plants. And it has a systemic effect against roots. For example, we see, okay, the applicator go on the top of the plant and then through the root. We have one pole here on the front and the other pole on the back. And then the circuit is closed in the system and the electricity flow. The working speed is higher. Till now on the agricultural sector, it's about 10 kilometers per hour. We should also know that in some cases, this high speed of 20 or 30 kilometers per hour is not the focus. I mean, for us in our project, it is a focus, but for previous research for agriculture was not the focus. So this high speeds, they were not tested before, and we are trying to test them now. It is also low power requirement. We can also conduct this research or this work with normal generator. The challenge is here the compatibility with electrical components on the track. The frequencies sometimes turn down the other systems, the security systems on the track. So this has to be changed and to be investigated. And there is an effect dependent on dry soil. So for this, we need that the weather conditions are good, or at least dry. Why? Because if the ballast is dry, then then the plant will have less resistance, and then the electricity looks for the less resistance way to close the circuit. Go to the next one. Our future work, is testing the system in track trials and the data analysis. So we will test the methods individual and in combinations. We will try to find out working parameters also for upscaling. For example, if you need more several doses and if you need some units behind each other, then this is what we are trying to reconstruct with several treatments. And then we also analyze or assess the energy requirement, frequency of use, the speed of the overall system, and operating cost. And afterwards, we go to elaboration of recommendations for their application. So which areas can be treated with these methods? Where do they work? Which safety measures we need to take? The effectivity against different plant species. Not all species die with electricity, not all species die by pulling out, and the potential for improvement. I have one last slide. Our conclusion is there is no the method. You said we don't have this dream method that kill all the plants, work fast, is good for environment, and can do everything. There is no the method. This is for further development. We can direct the methods toward plant species in working areas. As I said, some species die with heat, some species die with cold, with electricity, and so on. So for this, it would be great if we have a database of the weed control needs according to the track areas where those certain species grow. I think this is a challenge also for chemical weed management to know exactly what are we treating and for how long and how green, how much green can we tolerate on the track. Yeah, so intensifying dialogue between industry and science. I think, of course, we don't have the pressure that we have to provide a solution that we can apply immediately. We have some freedom in this case. But still, innovation needs room for maneuver. So we need this space, this freedom to try new solutions. And I would like to get out a bit of the box. We have been trying to create solutions like this, solutions that are coming from the rail vehicle. But what if we have solutions that we are under the rail vehicle, for example? We have this kind of flat robots. I mean, I found this picture online. It's not something part of our research, but non-chemical methods, they are slow and you have to come very close to the plant, otherwise they cannot work. And you have this requirement of not avoiding the traffic. But what if we apply them independent of the traffic? What if we are close to the soil? What if we're doing something different? Yeah, there is still a lot to analyze here. Yeah, so thank you very much for your attention. And if you have questions, then I'd be glad to answer if I can.